My name is Luke, and today we are going to be covering aquamarine. I am still not feeling well, but I've managed to pluck myself out of bed and lure myself into work in order to film the intro for a tutorial so that I can go home and narrate it from home. But today we're going to be covering aquamarine. Before we push any further into the depths that is aquamarine, it's important to point out and credit appropriately that the first video was provided by Fine Art Minerals and the second specimen was provided by Gail Coper's Span from the world-famous Span collection. The name aquamarine comes from the Latin words aqua, which unsurprisingly means water, and marina, which loosely translates as of the sea, which is a vaguely poetic reference to its colour. Aquamarine is a variety of beryl, so it's the broader mineral group with the chemical formula beryllium aluminium cyclosilicate, or more formally, beryllium aluminium silicon and oxygen. And I will stick the chemical composition up on the screen for you. Now, beryl is a cyclosilicate, meaning its silica tetrahedra are arranged in 6-membered rings, which is a hallmark of this entire mineral series. So the base mineral itself is completely colorless. This variety is called goshenite, which I've covered extensively in other videos, but beryl is famous for hosting trace impurities that turn it into a veritable panoply of different gemstones. These gemstones are generally named because of their color, but they're all varieties of beryl. So you get emerald, which is green, morganite, which is pink, bixbyite, which is red, and of course aquamarine, which is blue. Now, aquamarine tends to form in sort of long hexagonal prismatic crystals, often transparent and sometimes very large, and they also form in pegmatic environments where they slowly cool in fluid-rich solutions, which are ideal for growing beryl crystals more broadly, and some aquamarine specimens can actually reach lengths of over a meter. Physically, aquamarine has a Mohs hardness of 7.5 to 8, meaning that it's actually quite robust, making it tough enough for daily wear, and it also tends to be relatively free of inclusions, unlike things like emerald, which are famous for their impurities. In terms of its luster, aquamarine tends to exhibit quite a glassy luster, which is also known as vitreous. If you hear the term vitreous being thrown around, it essentially translates as glassy. That's what that means. So this makes it a favorite for jewelers who want brilliance without drama or fragility. A great deal of aquamarines are actually heat treated to enhance their blue color, so naturally they exhibit a greenish hue due to the presence of iron 2, but gentle heating, usually around 400 to 500 degrees Celsius, can actually reduce that green and shift the color towards a more distinctive sky blue. This makes it infinitely more marketable, and the treatment is stable and widely accepted in the gem trade. It's not contentious because it's not being sold as something that it isn't, like you see with things like baked amethyst being sold as citrine. This is merely an aesthetic treatment and is not really overly controversial. But aquamarine also exhibits a vague pleochroism, so it can show different colors when viewed from different crystallographic directions, typically blue along one axis and then nearly colorless or greenish on another. So cutters often orient the gem to maximize the bluer tones, largely because they're more popular. So you can find this in various different countries. However, certain countries are more famous and notorious than others for exhibiting fantastic examples of aquamarine. My personal favorite is Pakistan. However, you can also find wonderful examples in Brazil, Madagascar, Nigeria, Russia, and even the United States. In fact, there is a very interesting show called The Treasures of Mount Antero that I would definitely compel all of you to watch. It's great. In certain situations, aquamarine might be confused with other materials that exhibit some of the same aesthetic properties, things like blue topaz, which is generally an extension of a heat treatment and doesn't really occur naturally very often, or blue apatite, which is perhaps more common. In fact, contrary to wide understanding, the word apatite actually is derived etymologically speaking from the term deceiver, largely because it was very often confused with beryl, because in many situations it exhibits much the same morphology. However, they are very different. For example, aquamarine, in the case of topaz, is softer than topaz but much harder than apatite. In terms of crystal shape, aquamarine often forms well-defined hexagonal prisms, while blue topaz tends to have an orthorhombic habit. Pleochroism, for example, is another diagnostic. Aquamarine displays this, whereas topaz absolutely does not. In terms of color saturation, aquamarine's colors and hues are typically more subtle and watery, while treated topaz tends to have a more electric blue tone. This is variable depending on the treatment because you can get topazes in various different hues of blues. However, the colour is still fairly distinctive when you contrast it with aquamarine. So some general takeaways or summary of this video. The takeaways are that aquamarine is a member of the beryl family. It is the blue variety, which shares crystal structure with emerald and morganite, but differs in terms of its underlying trace elements and its colour. That colour comes from iron, and it can be enhanced with heat or left natural if it's already well saturated. Other varieties of beryl, like Heliodor, for example, also gets its colour from iron. However, it's at a different oxidation state, which underpins the difference in colours. In a relative sense, it's hard, it's clean, and well formed, making it ideal for both jewellery or display specimens. My preference being display specimens, especially one like this, which is objectively magnificent. It also has fairly long cultural and historical significance, with alleged ties to everything from ocean voyages to royal regalia, as people used to believe, apparently, that casting this into the ocean was a way of placating characters like Neptune or Poseidon. However, in my fairly extensive experience of researching topics like this, take little anecdotes like this with a grain of salt, because very often they are kind of shoehorned in and don't have a great deal of evidence to actually support them. This might be true, maybe sailors did this, but also take that with a grain of salt.